Good afternoon, good evening, good morning, fellow colleagues from the IHSI conference. I'm Flemisch, Professor for Human Systems Integration, and it's my great pleasure to give you a keynote on human systems integration, especially on the past, the present, and the future. I would have preferred to do this with you personally in Italy, to drink a good bottle of wine and discuss all the issues of human systems integration. Instead of that, we are sitting in our home offices, but nevertheless, we can connect, which is for me like in a science fiction, and we can still communicate. Why should you invest 1 hour, 20 minutes of your time in this presentation? Allow me to share my slides here. And yes, we are in COVID-19 times, but COVID-19 might not go away, but the pandemic hopefully goes away and other problems will stay. Look at this accident of several cars, Tesla also involved with a so-called autopilot system. Several people died. Or this here, aircraft accident of an Boeing 737 MAX. 2 accidents happened like this related to autopilot problems. Several hundred people died. Or this, a train wreck in Germany due to the inattentiveness of an operator, and also several people died. You're all aware of the Dieselgate and also, of course, of global warming. And I'm deeply convinced that, first of all, it's not a far away problem, but it's a problem that could affect everybody of us, you and me, as victims of such accidents, or also as human systems integrators, as engineers who are involved in that. And also something like global warming will affect us sooner or later. And I'm also convinced that human systems integration is a key discipline to solve those issues, and also that we don't have all methods to really solve those issues. Who am I that I can speak about human systems integration? My first contact with this kind of discipline was in the 80s. We were investigating these kinds of fully automated vehicles. And the question was, how do we involve the driver? And I went back and forth between different domains in aviation, in the car domain, also in defense. I'm lately involved also in human autonomy teaming issues on the ground and in the air, also in Industry 4.0, and also in a discussion, for example, with politics, where I'm representing Germany in the NATO Human Factors in Medicine panel. And here I'm also debating in the Bundestag about issues of human systems integration with these kinds of vehicles. I'm located in Aachen. The RWTH Aachen University is one of 2 elite universities in the engineering realm in Germany. It's member of the Idea League, together with Delft, Chalmers, Zurich, Torino. Our motto is thinking the future. The other entity I'm representing is Fraunhofer. It's one of the world's leading applied research organizations. It's mentioned, for example, by former President Obama as a role model for the National Network for Manufacturing Innovation. Our motto is, we know how. The team who has helped me to do this research and also helped me with this presentation is here. It's a very interdisciplinary team. We have engineers, computer science people, media science, psychologists, whatever you can think of to integrate, to do human systems integration. We have prepared an overlook over many thousands of years of human systems integration in just 1 hour and 20 minutes. The challenge we have is your attention span. Because of this special situation, we are not sitting together in one room, but separated. You might have your email programs just close by you. This study from Microsoft discovered that in 2000, the average human attention span was 12 seconds, and it degraded in 2013 to 8 seconds. A goldfish has 9 seconds of attention span. And we would like to ask you, please switch off all other stuff and allow yourself undivided attention. And we also give you some time So the 9 seconds are over. This was a goldfish test. So the goldfish are all away. The humans with hopefully undivided attentions are still here. And we like to challenge you in order to help us to keep the focus. In this presentation, we also hided at least one mistake. Probably there are more that are unintended, but please find these mistakes, send this to us, and the best one who finds the most mistakes will win a good bottle of wine from my wine cellar. We also give you a warning. Some of the content might be provocative. We offer some new wires, and we have more questions than answers. And we invite you to a dialogue. If you have other questions or potential answers, drop us a mail, and the best 5 contributions will be invited to do a publication with us. So with that in mind, fasten your seatbelts. The journey begins. We start somewhere in the very far past. Look at those wooden spears. They were found in 1995 in Brunswick in Germany. 6 spears, about 5 foot to 6 foot long, very well carved. The tip was fire hardened and obviously very well adapted to the bearer. Replicates of this spear were given to athletes and they were able to throw those spears 60 meters very accurately. So a very early example of a precise weapon. What do you think how old these spears are? If you think something about 10,000 years, you are in good company. That's also what I thought when I heard this story the first time. Hold your breath. They are 270,000 years old. That's the most conservative estimate. And what does this have to do with us? Well, it immediately becomes clear when we look at kids, for example. Everywhere on the world, they all play with spears, whatever, at least until a certain age. Also, girls play with spears. They might play a little bit different, but it's very into the human. And what they also found that near this site where the spears were found, also horse bones were found. And they reconstructed that obviously this tribe, it was not Homo sapiens at that time, it was Homo heidelbergensis, rounded up those horses, speared them and ate them. And it was not only one Homo sapiens, he would have had no chance, but several Homo sapiens that obviously were very clever to round this up. And for us, it's not only an example of human factors, of a best adaptation of this tool to the bearer, but also of human systems integration, because the organization was also very important. The technology, here obviously an opponent, and also the environment. And here we are, right away, human systems integration 270,000 years ago. We might ask ourselves, why do we need an opponent? And I will come back to this question a little bit later. If you want to read more about this, especially why this was important to us, Michael Tomasello describes how this was also important to develop our intelligence and also our language. And in this article in the Scientific American, it's described how then Homo sapiens 70,000 years ago left Africa with new weapons, but also with one ultimate weapon, and they call this cooperation. They were especially able to cooperate very hostilely against other species and taking over the planet. And these are our forefathers, so to say. We also have other forefathers like this fish, who was the first one who crawled to the dry land. If you want to read more about this, this is also a fun book to read. So we have some history in us. And I ask you and ourselves, how does this continue? So the problem is this is also a moving target. It's moving and also it's with a feedback loop. So obviously with our tools, we are also influencing ourselves and our development. So we are also shaped by what we build. And human systems integration is the key. So it's not only about tools, it's also about ourselves. Who do we want to be? This is one of the lessons we already learned from this early example. When we look further in history, very fast forward of several thousand of years, we see that one of the key issues was not only tools, it was also cooperation with nature. We somehow tamed the fire. Here an early example, then later on we tamed fire and metal together. We tamed water in a certain way, and also we made use of wind. It sounds trivial in hindsight, but it were very, very many steps of integrating certain effects. Brian Arthur has written this wonderful book, The Nature of Technology, where he describes how we manage to get these effects together and be innovative and innovate our things, our way out of trouble. We also went into a cooperation with plants. This was a key issue. Yuval Harari describes this as one of the most striking revolutions, that we did not walk around anymore, but settled and then tamed also plants. And it changed our life very much. It also changed the life of these plants. And Harari describes this as a kind of symbiosis that we did. And it was also possible not only with the plants, but also with the help of tools. You see this here. And if you take a closer look, it was also not only a cooperation with plants, it was also with animals, for example, like horses, here like dogs. Also, we managed to tame some birds. Well, whether this is a symbiosis, we could argue, but Harari says, yes, it is. If you would look at planet Earth from above, you would see more cows than humans, and then decide as an alien, oh, it's a cow planet. And we are the ones who serve the cows so that they can thrive in the numbers. And also we managed to tame also some insects. Now, the way how we did this, how we integrate those effects, how we integrated technology and those systems was more like a craft and maybe also like an art, but it was not for a very, very long time, not like a science. What made it science? Also, let's look at a couple of examples. At this guy, Aristoteles, over 2,000 years ago, discovered that things form systems, and he was the first one who described a system which is an integral part of human systems integration. So he says, the whole is more than the sum of its part, and you see here on the right side an example where you see those forms, and only when you see it from a correct perspective and you put light on it, you see that it's a system behind, and this also enabled our system thinking, was the first spark to do that. This other guy, we are in Italy, at least virtually, one of the most famous Italian, Leonardo da Vinci, he integrated science and art in a way that is still striking today. He drew this guy, the Vitruvian man, Homo ad quadratum et ad circulum. It goes back to an old Roman, Vitruvius was an architect who formulated that architecture should be formed according to the human body. And if you look closer to churches, you also see that most of the churches are formed like a human body. And this is a symbol also still today, what happened in the Renaissance, to put the human, the individual in the center, and then focus on it and focus on the growth of the center. And it's not by accident that many parties associated to human factors have this in their logo, including the Human Factors and Medicine and Ergonomics Society. And also a striking example, what happened in the Renaissance. Let me give you another example. Another Italian, Giulio Antonio Bonazzone, drew this wonderful picture, the box of Pandora. It's an old Greek story where our hero gets a box from another, I don't know, Greek creature, and he opens this and out comes a lot of evil stuff. And finally, at the end, some hope comes out. Now look at this drawing. It's still the box of Pandora, but it says space, hope. It says concordia, unity, right? Felicitas, to be happy, to be lucky, equitas, to be equal, libertas, to be free. Holy moly, this was 1570, 700 years before the French Revolution, and it sparked this idea that we could really innovate our way. We opened the box of Pandora, and despite what the church says, we innovate our way out of the problems. Talking about the church, this guy is also important for our understanding. Galileo Galilei, another Italian, just by accident. We are in Italy, right? He formulated the Earth spins around the sun, was arrested for this in his house, died also in arrest. Compared to his fate, our COVID-19 lockups are nothing. Several hundred years later, it took several hundred years until the church acknowledged the heliocentric model and rehabilitated, in 1992, rehabilitated Galileo Galilei. What we inherited from him is the mathematical experimental method to formulate a problem from observation, to analyze this, derive predictions, compare results from systemic experiments. This is the good part. We also inherited maybe a couple of difficult parts, strongly mechanical analytical worldview. He tried to formulate every problem in mathematics. In human systems integration, we know that this might be problematic. And he also experienced and founded a strong separation of science and the spiritual realm, because he was very much hunted by the church. This is no longer the case, luckily. Also due to the Enlightenment, we see another example, Wilhelm Friedrich Hegel, also part of the Enlightenment. And he formulated that when you think about one thing, you can also think about the opposite. And you have to polarize and then to balance those opposites, and then also find something in common, synthesize this, and you can also extend this way to other polarizations. And this is became later known as thesis and antithesis. And also the balance and synthesis of thesis and antithesis is the base of almost every science we are doing today. And we will see how we can use this later. And it's one of the core ideas also of the Enlightenment. Fast forward once again. We invented many, many more things. I can't name it all, maybe just a few. Electric generator, the first airplane. This guy, Otto Lilienthal, observed birds for years, wrote a book about it, and then he built these wings and finally flew himself, also killed himself. But what a story, unbelievable. Invention of cars, of the first programmable computer, the robots, and so on. So within a very compressed time, obviously a lot of innovation happened, and we are not yet through that, right? We are still in this very compressed time. This was the view from above. Let me also allow me to give you a personal view. One of the oldest people I know personally is my grandfather. It's this guy here. And grandmother, I inherited the teeth, by the way, from her. But he was a blacksmith, and so he worked with fire, he worked with metal. He started probably in a very old-fashioned way to work with that. And then innovation came, right? And it was the telephone, probably, where he called his later wife then. The photo was done by this photograph. He had a first typewriter. The radio came. Oh, and it was distributed all over Germany, because the Nazis also especially pushed this radio and pushed their doctrine with that. Also new technology like the Zeppelin came, the airplane, the jet airplane was invented. He tried to stay out of the war, but was unlucky that his boss was in the resistance, but was caught, Graf Stauffenberg, Duke Stauffenberg. So he was sent then to Russia to serve for ammunition trucks with animals and horses once again. He survived the war, almost a broken man, but luckily he survived. My Norwegian grandfather was not so lucky. He was in the resistance on the other side fighting against the Germans and did not survive that. Now, what can we learn from this? What we can learn is also that technology has a real impact on things. Let me give you an example from this time. In 1918, this book was written, Attention Tanks, Achtung Panzer, by Heinz Guderian. In 1932, first exercises with these kinds of tanks were conducted with paper and wood mock-ups. In 1935, 2 units of these new tanks were ready for deployment. And in 1939, they already had a decisive effect on the war in Poland and France, despite a ratio of 1:2 against the German forces. Against the German forces, right? And it's an early example, not only of a technology, what was the key issue, that these tanks also were organized in a specific way to operate fast forward, and they were controlled also with a new other technology, with the radio I showed you before, but a two-way communication, so they could be controlled. So we see this is an early example of disruptive human systems integration. And indeed, a lot of these things that were invented in the Second World War, we still use in our human systems integration. And also, we take this example also to look out for disruptive technologies. And it's not only in the military, we see this in all domains, that things are happening fast and new combinations of technology really disrupt a whole market and can also affect you in your business. Fast forward once again, Second World War, terrible experiences. And then we try to reintegrate NATO, United Nations, NATO, European Union, what a bliss. NATO as one of the strongest defense organizations. Also early examples of automation that we are still referring to. We were in a space race. And then our American colleagues managed to land on the moon, a first announcement in '61, and then in '69, they really landed on the moon. The moon landing, the whole operation, costed $120 billion in today's currency, and at the peak time, 400,000 people were employed. The Iraq War, in comparison, costed about $700 billion, and 150,000 people were killed. So you see, the moon landing was relatively cheap in comparison. If you want to learn more about the moon landing, you can read this at the MIT Engineering Apollo, the Moon Project as a complex system. What do we get out of such space programs? For me, one of the most valuable insights is this picture, that we see the Earth as one tiny system where we are sitting on, one spacecraft, if you may, where everything is connected and that somehow has to be stabilized. And we have a second thing that we inherited from that, but I will come to that later. You might guess what it is. I was really fascinated by this. My first moon landing I saw with 3 years, and I decided to go to NASA. And I also succeeded later on to do this, and never regretted this. But I really grew up then in the 70s and 80s. Some of you might remember this time. These were our smartphones, very mechanical. You threw in coins, they ticked away. These were our first electronic devices. This was a video recorder. This was my car. No assistance systems at all, but a lot of freedom. I really like that. First CD player, too expensive, not for us. First computers, Apple was also too expensive, but tinier computers, we were the first ones who programmed this and showed our teachers how to use this. I was also fascinated by aircraft, of course. This wonderful airplane was brand new at that time. It's now already retired. I sometimes also feel old when I see this story. This was the first aircraft I was allowed to work on and drill holes in. They still fly, but they will also retire in a couple of years. And of course, the space race went on with these kind of wonderful systems. Once again, a system that's retired. What does this tell us? Holy moly. But the most precious invention that we take out of this development in aviation and also in the space realm for me is, of course, human systems integration. This is the reason why you are here. Was invented probably in the military and in the space domain, first described by the Department of Defense here on the right and by NASA. And NASA said at that time, it's an umbrella term for several areas of human factors research that include human performance, technology design, human-computer interaction. And we focus on safe, efficient, cost-efficient operations. And this was also a kind of a revolution, that you combine not only technological factors, but all these factors together. And I became early on already hooked by this idea, because it was also, it still is very, very complex what we do. The first handbooks were written that already also released themselves from the realm of military and also from space. There was still a Cold War going on. And a lot of research in human systems integration was invested also then, was done in this domain. I myself became a technical control officer and later on deployment officer. And at that time also something happened that most of you might not remember, luckily, but we almost got extinct as humans. There was an event when there was a false alarm on the Russian side, and all these defense systems were still up and running really heavily. And almost, so this Russian officer, he had the order in this case of event to really start a strike back with nuclear weapons, and this would have caused the extinction of everybody of us, quite sure. But he thought twice and three times and then decided not to do this. And there's a wonderful, very well researched movie also about that, The Man Who Saved the World. I can only recommend this because these kind of systems, they are still up and running. So we are not out of the danger zone yet. Also at that time, it became obvious that these computers are not only really a bliss, a really good thing out of the box of Pandora, but also there might be a certain gap between the human and the computers. This was a drawing I was fascinated on as a young engineer. This is Don Norman, the guy behind this drawing. A recent photo, he's still alive and hopefully well. And he inherits us wonderful books like this, Things That Make Us Smart, where he says that we have to, with this increasing gap between the technology, to defend human attributes in the age of the machine. I was also influenced by Don Norman. He always tries to cross over between different domains, also to arts. And I was studying in Munich at that time. And I was fascinated by Italian architecture here in this wonderful museum, and also by Italian artists. Maurizio Nanucci, he really brought it to a point what was the most essential mental operation at that time. It was, you can imagine the opposite. So Second World War, you can imagine the opposite. Peace, maybe not a good technology, you can imagine the opposite, good technology. And this was also what really pushed us forward and what still is a big topic also in the world. And it pushed forward, on the one hand, even better space systems. Here you see the International Space Station that grew heavily at that time, but you can imagine the opposite also affected other people. So you see September 11th also happened because there was also an alternative view of the world. Our economic system went almost bankrupt for a certain time with the Lehman Brothers. A lot of really good conferences were founded. One of them was the IHSI conference. And now we are in this very fast forward in 2021. And in this conference on intelligent human systems integration. And somehow, despite COVID, I feel like I'm in a science fiction. I mean, we can't travel, but we are connected and we see each other. Well, at least you see me now. I would love to see you maybe then on the conference. We have all these wonderful devices, computer power that was, when I grew up, was filling a whole room. Now I have it in the pocket and I'm connected to almost the whole knowledge of the humankind. I can see almost every city. I can chat with people there in real time. The cars I drive, no, that's not my car, this Mercedes. I only borrowed it. I couldn't afford it, but it's more like a spaceship, even more modern than any spaceship and any Star Trek series in the 80s and 90s. It's incredible. It has more computers on board than the space shuttle. This is the setting I'm now using in order to give you this presentation. And it's more looking like a cockpit and even more modern than any cockpit of the 80s and 90s. We communicate via the internet. Here you see a snapshot from the communication with my students. And I tell them I'm feeling like in a science fiction, and they say, what? Why? For them, it's very normal, right? For them, it's not science fiction. They grew up in that. And I said to them, wait, things are moving so fast that also in 20 years from now, much of the technology that we use today will be much further developed, and we have some disruptive technologies still coming up. And hopefully in 20 years, they will come back to this and say, yes, maybe you are right. One of the most wonderful insights with all the downsides of this pandemic was this, that I discovered that I can also connect to the rest of the family, even if it's hundreds of miles away. My young niece, 7 years old, she's asking me all kinds of questions, what I'm doing in my research. And she's my most critical counterpart in the discussion about the world, I have to say. And we'll come back to her a little bit later. So looking about the present, how has human systems integration developed? Well, we see we have a couple of organizations dealing with human systems integration. So the International Council on System Engineering has also found a board, especially on human systems integration. And the IEEE SMC, System and Cybernetics, has a very long history. They don't call themselves human systems integration, but if you look closer, it's about interdisciplinary aspects of system science and engineering, human machine systems. So this is human systems integration par excellence. In NATO, we have the Human Factors in Medicine panel with one of two regions, especially dealing with human systems and behavior, also human systems integration. And our colleagues from the Human Factors and Ergonomics societies, they're also designing for people in systems. So it looks like we are a growing family. And I think this is really good. If we look at our conferences, we have a couple of new conferences also. The ICHMS started last year, the IHSI that's growing every year. So it's really a thriving community. If I look back in history that it started in space, we did a closer look. Now, where are we now in 21? And we looked at the contributions of your contributions in this conference, and our students then depicted that, well, it's production, it's industrial engineering, it's inclusion, it's health, education and training, basic research, automotive, and others. Probably space is others. So we see that human systems integration is really now further enhanced than being just in aviation and being just in defense, which is really a good sign. And it's a lot of know-how probably from aviation that now is integrated also in other domains. And this is the right way to go. So being not only interdisciplinary, also being interdomain, and we also see increasingly that also new methods, new know-how is generated in these other domains, and then is channeled back also to the original domains of aviation, space, and defense. And this is the way to go. We also see this in defense. I ask our students look at what contributions are from the military realm, and they said, well, it's only a small part, small portion, and majority is already bigger. I'm already concerned a little bit about the military domain, that these get two separate worlds. And I hope somehow that we can keep this together also as a community, because we can really benefit from each other. So this is a really cool development that we have already in there, but I'm also convinced that it just started, that human systems integration, especially intelligent human systems integration, has a good chance to grow even further, and with it that also we can grow with this domain. And there are a couple of hot topics that we might have to address, and I try to now also structure this. We know the future is open, so it's speculative. It opens up more questions than we have answers. It's open for debate, so I'm also curious on your feedback. And we structure this in a way that we're talking about tension fields. I think we can structure this easily, nicely in tension fields. And we will see, before I come to this guy, we will walk along these tension fields and see what the challenges for human systems integrations are. Now, when we look in the future, it's also worth to look at what technologies are pushing our future. And we had a workshop last week at NATO's Programs and Plans workshop. This is the chief scientist of NATO, Brian Wells. And NATO is in the moment working with those technologies especially. Biotech is really thriving. We benefit in COVID-19, right? The US has founded a space force and is now feeling themselves in the space race, especially with the Chinese colleagues. Quantum computing is on the leap. And we learned, for example, that if you try to encrypt sensitive data like photos, they can be cracked easily in 10 or 15 years. So if you want to hide photos from your grandchildren later on, burn your hard disks. Don't try to just encrypt them. This will not work. We have novel materials that will change a lot of things in the world. We have new kinds of weapons, hypersonic weapons that condense time. That's really dangerous. I will talk about this a little bit later. And not surprisingly, big data is still an issue, artificial intelligence and autonomy. And I will especially focus on this interplay here of artificial intelligence, autonomy, data, and of course also the human-machine interfaces. They play also a role in that. So this is what NATO thinks. In the civil realm, we feel an increasing uneasiness about this development. The Economist is talking about the march of the machines, the rise of the robots, the return of the machinery question. Computers could be smarter than us. Google is developing a DeepMind system. And I can encourage you to this book. Nick Bostrom wrote about superintelligence. And his metaphor is that we humans are like little mice debating whether we should create an owl to protect us from other enemies. And you might guess that this might not be a wise idea for this kind of little mice, and might also not be a wise idea for Homo sapiens. So there are some kind of caveats. This box of Pandora that we are now opening, they might also have some challenges that we might have to address. We also see some pushes on the civil side. Yes, COVID-19 is right, a big accelerator that we feel. We still have global warming. It's now maybe a little bit in the background, at least in the minds, but it will come in the foreground even more massively. These are the pictures you saw a couple of weeks ago. The politicians, some of them might not be in office anymore, but the ideas are still out there. So this is quite a provocative mixture. So the Bulletin of Atomic Scientists, they come out with a report every year about the state of the world. And they have also shown us this statistic. I don't want to go into too much detail, but if you look here at this curve, the declining trust in institutions over the years from the 60s here to today, and you see that especially in the US, it's heavily declining, and also in other countries, the trust is declining, and trust is a base for a lot of things, especially for cooperation. And they also, you know, this Bulletin of Atomic Scientists, they also operate a clock. They call it the doomsday clock because of the Cold War and this danger to really kill a lot of people in a nuclear holocaust. And the doomsday clock was already at 10 to 12. So it was a little bit better in the 90s and in the 2000s. And recently they put this to just 100 seconds to midnight to doom, right? And they say the lethal and fear-inspiring COVID-19 pandemic serves as a historic wake-up call, a vivid illustration that national governments and international organizations are unprepared to manage the truly civilization-ending threats of nuclear weapons and climate change. And the lesson I take out of COVID-19 is shit really happens. All these forecasts, it was almost forecasted. There were studies about this. They were neglected and it happened. And now we are in this trouble that could have been prevented right away. And what about if similar things could be true about nuclear weapons and about climate change? Shit happens. Okay, so the future of mankind could be also, if we are not reacting, more like this, right? A little bit exaggerated. Maybe a couple of us survive. Okay, we could say, yes, that might be the natural fate. But wait a moment, there's other people who want to live, right? My little niece has a life expectancy until 2102. And what will be her future? And also, of course, we also want to live. Your kids want to live, grandkids, we want to see them, want to enjoy life. So what do we do about this? You can imagine the opposite. Once again, Maurizio Nanucci, we are in Italy here. What is the opposite? What can we imagine? The scientific base for the opposite is dialectics. It's about thesis and antithesis. So how can we apply this to human systems integration? First, we have to polarize. What are our tension fields in human systems integration? Yes, we have humans, we have technology, we have organizations, we have the environment, and we already see this is quite some tension in there. We have critical and constructive approaches, we have objective views on the world, we have subjective impressions, we have fast and slow processes. So I think this is a way we can structure at least a discussion on human systems integration and then talk about how we balance this and synthesize solutions that help us to innovate our way out of that. So we already see balance is really a hot topic. The first field we might be already quite good at, the tension field of critical and constructive. Constructive, we make systems work and bring benefit. That's what we all work for as engineers, computer scientists, and so on. Critical systems might have flaws and bring harm. The human factors community was at first entered with a critical attitude, and rightfully so. And what we do now as human systems integrators, we combine this, we build a synthesis, and the synthesis is we support to balance the risks and chances of new technology. That sounds trivial, but it's also an increasing development that will reach every realm and every domain. Let me give you an example on the defense domain. And of course, we balance here all the new innovations that come out of the box of Pandora. So as an example, when we develop nowadays new defense systems, for example, based on robots, based on autonomy, we are obliged, we are urged to involve those guys here and panel on the regulation of autonomous weapons. And they always then discuss critically, okay, what side effects this has. And there will be no weapon system that is not approved by such panels. As an example, we are doing a bigger system also development, FCAS, a future combat air system, France together with Germany. And an integral part, an important part, is an ethical board that discuss the side effects of such systems. And these kind of boards, they will be around in all kinds of domains. So control the side effects. Let me show you another tension field that we have here between mass production and individual production. Yes, we are still at the peak time of mass production that makes many of our products affordable. But we also have a new technological push. These are 3D printers. This is nothing new, but it might change our world more significant than we think so. For example, if you look at this video, how building will be done in the future with a 3D printer. First buildings are already printed, and you can imagine if this sparks out that not only the way how we build houses, for example, in a round shape because the printer is round, will be changed, but also the market, of course, the labor market will change. And here on the right side, you see the example from the medical realm where maybe organs can also be printed. This is science fiction yet, but the people who do the research here are confident that within 20 years, we will be able to really apply this. And 20 years, we know this, the older ones of us know this, is not a whole lot of time. This puts us under a lot of stress. Why? Because systems will be not a mass production of one and the same system, it will be batch size one. So every system will be individual. And this is what makes it difficult for us as human systems integrators to really state what is the problem about the system and what is good about the system. So we have a diversity challenge. How do we focus on this? How do we solve this diversity challenge? And there's a really brilliant innovation coming once again from architecture. Christopher Alexander wrote this wonderful book on pattern language in the 70s. and our colleagues from the computer science then applied this to design patterns. And we are already working also with colleagues worldwide on applying this to interaction patterns, especially, for example, for machine cooperation and cooperative movements. And I'm convinced that the pattern approach is really an important one where we should work together so that we can handle this diversity. How do we handle engineering and experiment? That's like the classical dichotomy when the human factors people entered the debate. They wanted to do experiments. Okay, yes. And the engineers wanted to do engineering. And we have still a vivid debate going on how we handle this. And let me go into one ongoing debate that we have also, for example, with Keyboy, but also other colleagues. What is the balance of the human parts and the engineering parts? And in this debate, we also discussed the V model that's quite famous for building complex technical systems, where you go then from generic requirements into specific codes or into the detail, and then you reintegrate again. And over the time, we also discovered that this is iteratively. And the debate that we are leading now is, okay, this is more a classical view. So we did a lot of engineering, and then human factors came into play and said, in the beginning, requirements are like that. And maybe in the end, they also tested. And user-centered system design, user-centered said, okay, focus completely on the user. So do human factors and leave the rest alone. And we also know, okay, nice try and a good idea to focus on the user at certain periods. But in combination, it would not work because the technical folks said, where's our part now as engineers, as computer scientists? It was not a good offer. It was a good offer for the users, not a good offer probably for the engineers. This might be a little bit provocative, but allow me to also provoke. And then we debated this picture. Okay, is it human factors, does or the specification, and then the system engineers, they build these systems and test it. And of course, you already see that there might be some flaws in this debate. So the model we are arguing in the moment is that it's a combination where a lot of non-technical factors like the humans, like organization, are introduced in the very beginning, and then they are increasingly blended with also technical aspects, and then these technical aspects are implemented, and then later on we reintegrate, and then the test, of course, is also done with the humans once again, with the organizations once again that test these systems. And the discipline that keeps it together, of course, is system thinking. So we should also, in the next version, put a frame around it, and it's system thinking and human systems integration can orchestrate this and bring this together. So this is work in progress. We have not yet published this, but I hope you can still contribute also to this discussion, and we get something good out of that. The working title is V Model of Human Systems Integration. And this is how we balance then engineering and experiment. And we also see that the experiment that is very tight, also tightly controlled, might be in the end, and there is some room in between, and which we have to fill, and also especially how we generate the hypothesis. Design, system design is a hypothesis in the beginning, right? And we somehow have to generate this, and we should do this systematically. And over the years, we have formulated also together with colleagues that we want to develop a human systems exploration as part of a human systems integration, as one certain phase of the integration. And we presented this already in 2019, so I will not go into detail, but this idea of exploration is also thriving also in the community. The key issue is that compared to the 70s and 80s, where you can imagine the opposite was the most dominant topic, that now the diversity is so high that we strive again to bring people together again in the same mental model mindset to do a design together. And this is quite challenging. So if I would be the artist, I would put this together. You cannot only imagine the opposite, you can also imagine the same. And imagine our imagination. This is truly our most capable weapon against any misery. So, and of course, we put these two perspectives together. They are not, they are contrary, but they have to work together in order that we get really good systems out of it. The way how we do this is that much earlier in the design process, we allow people and also our engineers, our human systems integrators, to work together, to play together. And we build up specifically equipped laboratories, which we call exploroscope. It's like a microscope or telescope, but focused on exploring things. And we are building up a new one here in Aachen now. And also other entities are applying this kind of idea in Delft, for example, or here the example of the DLR school lab, where they invite then students, young students, to play around with this technology and then play towards integrated human technology systems. We are allowed to play once again. So what do we play, especially regarding the interaction? What we see is a strong push towards visual interaction. So when you look at this example from the newest Mercedes Hyperscreen, you see visuals all over. Yes, you can interact with some of them per touch, but most is done in a visually very demanding way, very attractive, of course, but on the other hand, these drivers should also keep the eyes on the road. And what is the right balance? What we also see is that haptics, that was so strong also in the 70s and 80s with very good electromechanics, that this is going away and the world becomes more visual and also more abstract with that. And what we also see is in the research domain, revival, especially of the haptics, almost like a renaissance, and where we balance these modalities in a better way, and especially acoustics and haptics will be once again an important part. And it will be one of the challenges to bring haptics back. The way, let me give you an example, how we do this is that we direct the attention of drivers, also of pilots, in the region where it's most needed. For drivers, it's on the road. We overlay information there on the road, and then we give them also haptic inceptors where they can interact. They are active also in a way that you can feel resistance and also feel signals there, for example, if a danger is there. And we, once again, integrate this in kind of patterns, which we call maneuver gestures. And we know that this gesture-based communication is also that many colleagues worldwide are now investigating. And the patterns behind the gestures, I think this will be a base also for a good human systems integration. And my colleague Guy Boy in France has written this wonderful book on tangible interactive systems, where he's also trying to spark this renaissance of haptics. And he also states that especially when you can grasp things, that then you start really to understand it. And without the haptics, then the impact is not so good of those systems. Another tension field, reality versus virtual reality. So we have a wonderful reality underwater, above water. We have an increasing human-made reality. And, well, ironically, maybe some of the natural reality is fading away, which is very, very unhappy. On the other hand, our virtual reality is becoming brighter, it's becoming more immersed. And what do we do about it? This trend is far from being over. So it will continue until we have the complete information that we have now in a natural environment, also in a virtual environment. And this might continue for another 20 or 40 years until we really reach the maximum of our senses. But what is still missing is, of course, once again, the haptics. And the question, what we also try to do is to reintegrate this again and to combine those worlds. So we increasingly also see a mixed reality and a tangible XR. And what we do, for example, if you see this human here operating a virtual door, that he sees the door with his goggle on, but he can feel the door and operate the door with a mechanic device that really feels also like this door. And with that, we get a good combination, and we can then investigate also these systems in a much faster pace, already in a tangible way. Here you see the example in the development of a new heavy vehicle. And here you see also what this driver then is seeing. And here you see also what this driver is feeling and he can interact quite naturally. And you can also see that this mock-up is really fast. So we see this combination as, I think, a good synthesis of this both ideas of building real systems, real mock-ups, and also building virtual mock-ups. And on the other hand, we also see that a lot of big systems will also be almost developed a lot in the virtual world. Let me give you another example, what you can do with this kind of combination and with the virtual reality.
What happens when the last Holocaust survivor dies? Who will tell their story? And is there a way to be remembered forever?
Do you think you were brave during the Holocaust?
I don't look at it that way. I look at it as maybe being selfish because I wanted to live while everybody else around me was dying, was being killed.
The Illinois Holocaust Museum and Education Center in Chicago found a way to permanently preserve survivor stories in the world's first 3D interactive hologram exhibition. Much like Siri or Alexa, you can ask the hologram questions.
What is your message to us?
Young people who don't know what they're going to do with their life, my job is to insist, to instill in them that they have the ability to overcome all types of adversity if they believe in themselves and if they're willing to pay the price.
I think a stunning example of what we can also do with the technology. And it also asks a lot of new questions to us. What happens if we combine this with AI? Will we have AI creatures that look like holograms then? And we can talk to them and they give answers. And maybe we also create our grandfathers once again as creatures, and they then give answers. We may feed everything that a person published or drew, like Leonardo da Vinci, into an AI, and then we rejuvenate Leonardo da Vinci. And of course, this provokes all kinds of questions, what we really do with this technology as a society. And talking about AI, we also see a big tension field still since many years between autonomy, human autonomy versus machine autonomy, and also intelligence. And what the first thing we learn from Hegel, from dialectics, is if you talk intelligence, we also have to talk non-intelligence. We know this from humans, and humans also can be non-intelligent. This young driver with his smartphone is probably not the smartest thing to do while driving. And when we talk about AI, we also have to talk about non-intelligence of AI or dumbness, right? And we know from humans, okay, we have a certain way to cope with that. And we know that one human itself might not be probably suited. We have a big discussion about driverless cars. And this journalist here says, driverless cars, once they are on the road, human drivers should be banned. And I was electrified by this statement, and of course also heard, right? I love to drive. Maybe you are also love to drive. Being banned is quite a thing. And if we look in other domains, we have a similar development to fully automated factories, and we can ask ourselves, manufacturing robots, once they are in the factories, should human workers be banned? We see this in medicine, robotic surgery. By the way, this is teleoperated, so that we see that in the media, this is all mixed together, and we have to really clarify this. But surgery robots, once they are in the hospitals, should surgeons be banned? Teachers. Now also AI is being used in order to teach. And the question, of course, is teaching robots, once they are in a classroom, should teachers be banned? Law, we have now assisted systems on law. If once AI is in the courtroom, should lawyers and judges be banned? Politics. I can really encourage you to see this video. It's called the Kitty AI. It's a piece of art where this animated cat is telling us why it has been elected the emperor of the world. It's now ruling the world. And at first you think as a scientist, what a stupidity, right? This will never happen. And the more to listen to these arguments, you see, oh, there are a couple of really good arguments why this could happen. And one of the arguments is that this cat is really cute, much cuter than any politician. and also AI is much smarter. So once AI are in the parliament, should politicians be banned? Look at this photo, most provocative, of course. There's a whole industry now coming up with this delicate subject of love, and AI lovers are really in the making. And once AI are in the bedroom, should human partners be banned? Yes, I provoke. I know, I hope nobody is offended too much. Regarding provoking, a newly released development here in California, once again, where the box of Pandora is opened really fast. A new church of the AI god is even creepier than I imagined. And you can read this also in the internet, what they really did. But AI and faith, once AI is in church, should priests or God be banned? So we see there's a lot of tension. If you feel a little bit like this now, tense, this is exactly the tension that we have in the society. And in human systems integration, we are right in the middle of this battleground. And once again, Hegel, how do we solve this? Well, when we have problems, we ask our most prominent forefathers. You all know this guy. And he said, if you have problems, look deep into nature, and then you will understand everything better. And nature, this is also human nature. So in human nature, we have also cooperation. For example, these guys here, or girls in the cockpit, cooperating, keeping the aircraft safe. And indeed, this example has been used since many decades in pilots associate programs, for example, crew-assisted military aircraft. This was one of the programs I was also involved in. My colleague here, Peter Stütz. I can recommend also to read these articles from Jean-Michel Hock from the early 2000s on what is the base of cooperation. They are still very, very valid. Or this book also from Rainer Onken and Axel Schulte on system ergonomic design of what they call cognitive automation. Today we would probably call it also cooperative automation, and it's still very valid and relevant research that should be rescued. Many of you know that we also took other examples from the cooperation of humans with animals, and of course this example of a rider and a horse, where you have a high autonomy moving, but also the rider controlling this kind of vehicle, and we applied this also in these kind of levels of automation, where we said we can automate, lowly automated or highly automated or fully automated. And then we applied this over the years into control schemes, which were later called then shared control and also traded control. And we now call this also cooperative control. So both a human and a machine control, not only a vehicle, it can also be applied to a plant in a mutual way. And this was then also used to come up with these levels of automation by our colleagues from the SAE. Many of you are familiar with that. And what we see now also, that despite all critics of these levels, they are also quite useful to discuss about this share between the human and an AI or an autonomous function. And we also see this in manufacturing. And I have talked about that we now also see a feedback also of concepts coming back from other domains into the original domains. They are also talking about a degree of control intelligence and combine this. And I think this is really a clever approach to also structure this challenge field that we have here in human systems integration. We have also recently extended this concept going beyond the levels. We're talking about layers of cooperation together with colleagues from the Netherlands, from France, and also from Japan. And we see the traditional three different layers of operational, tactical, and strategic. We also complemented that with a fourth layer, cooperational, that's especially dealing with the cooperation. We humans are doing this all the time, that we are also talking about our cooperation. And then when we have a good cooperation, then we start to operate. We call this joining the blunt and the pointy end of the spear. So here the spear is again over 270,000 years of history. Now it's also still valid. So what we try to balance here is human intelligence and autonomous machine intelligence. And we bring this together, and these are control schemes, patterns that we can apply in many domains. And we see this also already by many colleagues thriving these concepts and also bring this forward, for example, in the medical realm, so in all kinds of domains. Under different names, we call this cooperative automation. Often it's called human autonomy teaming, shared and cooperative control, symbiotic driving, our colleagues in Delft, but it's very, very interrelated. Cooperation is at the very core of this. A question I have to you is, I'm still struggling with this idea of assistance and then also automation. What we also see is that the freedom that we had once in the 70s and 80s is also being refined and degraded. And yes, discipline on the other side, as an antithesis, discipline brings safety, but what is with our freedom as humans? And the question I have also for me and also to you as a community is, what happens with this freedom when we introduce now these intelligent machines? And how can we balance this freedom? Is it in a way that disciplined machines, they are taking the discipline and we can overrule them and be free to a certain extent? So what is the proper balance here? And I have more questions than answers. We also know that freedom is only one of several system qualities, and this plays together also with qualities, with functions, with costs, also with time. And in another contribution to the IHSI conference, we are talking about how to analyze this and how to balance this. So I will not go into detail in this keynote, but I would like to go into one detail. This is about time, because we have a really important development here regarding time. Mainly in human systems integration in all technology, we are talking about linear time. That's also what Galileo Galilei first, and together with Newton, formulated the first time. A time model where time just goes forward, it goes with the same pace all the time. But in human systems integration, we know with people involved, it's not always linear, and some time is other structured. Once again, back to our Greek forefathers, they have formulated a time concept called kairos. It's the god of the moment, sees the precious chance that you have there, and this chance is only there once, and you grab this half god by his hair, long COVID-19 hair probably, and grab him and hold him, or this chance is gone. And I ask ourselves, do we integrate our human machine systems in a way that they are also open for this chance? And then also there's an iterative time. The Greeks didn't have a name for it because for them it was so obvious. There's a wonderful movie, The Groundhog Day, where our hero wakes up every morning. It's a little bit like in COVID lockdown, and always repeats the same thing all over and over, and tries to woo this pretty woman, and then finally succeeds after many, many iterations. And of course, this is also a time concept that is valid for us. And we already have this as iterative approach for design, for example, and it becomes more thriving now, spiral approach also to design than the linear time model, which is more like a waterfall model. So we see time plays a role. And what we also see is a really severe challenge that time is accelerating. In the defense, we are talking about hybrid war, so combining different attack vectors, also, for example, in the cyber defense realm. Now moving to hyper war, which is a very fast way of war. It's almost like blitzkrieg. I showed this disruptive technology at that time. So it's the blitzkrieg of the 2020s. And NATO is really concerned about that, because in other domains, we have already seen, for example, in the stock market, that this fast acceleration can be really problematic and led to flash crashes. And then with new weapons like the hypersonic weapon missile, that is really difficult to intercept. These spirals might become unstable. And it has some reasons why this bulletin of nuclear scientists put the clock to 10 to noon. And I think the controllability of such systems is really crucial in the moment. So it's probably one of our most difficult tasks we have in human systems integration. Hartmut Rosa, I can really recommend this newly translated book on social acceleration. He describes this as a development not only in the military domain, but in all other domains as well, that things accelerate. Kahneman describes that thinking fast, thinking slow, when we have enough time, we think differently than when we are under time pressure. He's talking about a system one that's fast and effortless, and a system two that's slower, but it's also conscious. It allows conscious decisions. And a question I have to you, to our community is, how do we combine this and how do we integrate systems that they allow both? And especially that they are time sensitive and also allow chronos. Yes, this is what we are already good at, but also kairos and spiralos, this iterative model of time, and especially balance, fast and slow. So this is a challenge. It's especially related also that time and data, our attention span is also changing. I have showed you already the goldfish. There's a good video on the internet. The Swiss put it on about attention deficit effects in traffic. And this accident I showed in the beginning was also due to a limited attention span, and the operator his attention was diverted by a smart device, so-called smart device, and these accidents happened. Maggie Jackson wrote, maybe not a scientific, but an interesting book about an erosion of attention, that this might be really also a challenge or even a danger to our whole society. And our really professional colleagues from the US Air Force released a report. It's already a little bit older, but still very valid, on the title Fight Cognitia Fragmentosa. So the fragmentation of cognition due to attention diversion is really a challenge. And let me show you an example also from our own research that we already did in the 2000s, where we had people in the simulator. They drove a car with an assistance system or a partial automation. And in one instance, they were connected with this. And then when the automation failed, they were able to take over. So this is the green line. They were able to stay on the road. And the others, they were not physically connected. All two groups where their attention was diverted. And these who were not physically connected were not able to take over and crashed. And from this, we formulated that on this spectrum of all human control, all machine control, there are regions that might not be safe. We call this unsafe valley of automation, because the expectation might be that it's really automated, but the reality is, no, this automation has also failures. And we forecasted these failures and a lack of control then in 2016. And ironically, then a couple of months later, this accident then happened, the first Tesla accident. It happened almost exactly like this model. And then further accidents, the first accidents I also showed. The Uber accident is also similar. And we are now seeing applications popping up all over the place, where drivers here, a remote driver has the task to take over in case the automation fails. But in reality, this driver has no chance to really do this. But this driver has the legal responsibility. And this is a recent development. It's all over the place. It's really, really dangerous. Our colleague Madeleine Elish calls this moral crumble zone. We are using humans as moral crumble zones for failing technology. We have formulated this as a fragile balance of ability and responsibility, where double and triple binds might be violated. My young colleague Liza Dixon has formulated a really cool concept of autonomous washing. She says that what these manufacturers do, they say this car is autonomous, a self-driving car of a very self-driving company, but in reality it's not, and it provokes an overtrust where that then causes also severe accidents. So we see that we have some tasks also to do in the future. In the last year's conference on human machine systems, the keynote was by Cristiano Castelfranchi, And he stated that we are not building only new technology, we are building new socio-cognitive technical systems, and especially agreements and disagreements are an important part of such systems. And he says, viva conflicts, it's almost like viva Hegel, viva conflicts. We need those conflicts, and as a society to discuss those conflicts and to balance those conflicts. And some of you also know that this deliberately balancing conflicts also between humans and machines is also something that we investigate. Also other colleagues in France, for example, in Japan, we are calling this arbitration or dissonance management. And using this metaphor, which I cannot go into detail right now because Kronos is waiting to cut this off in a couple of maybe 10 minutes. So the ironies of these accidents, that all data was available up front. So in the Dieselgate, all data was available. In these accidents, the research was already available. This could have been avoided in these accidents. And nevertheless, the data was obviously not enough. So we have a systematic problem, and T.S. Eliot depicted this in this chorus. Where is the knowledge we have lost in information? And where is the wisdom we have lost in knowledge? So obviously, we have a severe problem of this chain of data, information, knowledge, and sense, wisdom at the end, to make sense out of that. Sense making is something that fabulous Carl Weick formulated in the early 2000s, that we should do sense making more, especially with our systems. The US National Academy of Science has also put this up on the forefront of their agenda. And I think we should also do a sense-making human systems integration and control this chain from information to wisdom, which is not trivial. We see that this integrates also the organization, technology, and the human. So when we think about human systems integration, and this is the picture probably from the 90s, already technology, organization, and human, what is missing? What is missing in the picture? Can you guess? Well, how about this guy here? This is, by the way, a true photo from Bangladesh, right? This might be somewhere out in the future what our grandchildren see. So it's about global warming, and how do these things relate? They are related, aren't they, right? And bring this together and solve this riddle is also something that human systems integration could address. And there's one thing, of course, missing here. And it's depicted also in this new report from the Club of Rome 2052 that states that we are still have some challenges and have some homework to do. And our homework, I think we have to do, is to integrate the environment also from the very beginning in our human systems integration. There's no way around this. So we see technology, human, always in organization and also in the environment from the very beginning. And this is not trivial, we know that. So how do we develop human systems integration also as a science? We have it as a craft, as an art. In the IHSI conference, we are also applied, we know that. But we also have to develop the research side, the science side of things. And system science is, we have already a very good base starting with the 50s. Norbert Wiener, for example, Stafford Beer, this wonderful model of an autopoietic system, how living cells organize themselves. And this still waits to be translated also and integrated in human systems integration. So there's a whole treasure now of system science and system research in all kinds of domains that we can use. And so human systems integration as system science, this is something we have to push. And my friend and colleague David Ebbing at Delft and I, we are dreaming of bringing back also what was the Macy conferences in the 40s and 50s, an interdisciplinary dialogue about how to integrate system science also even more into our individual sciences. So there is a lot to do, for example, how to translate from all these different domains of the world and in a systematic way with systematic system knowledge into, for example, deriving patterns from nature, applying them to technical systems and then instantiating them in a controlled way in the world. So there's also a lot to do on the scientific side. And one of the most important things that we have to address is not only system thinking. We have a lot of insight already how we do things better. Also global warming, also these accidents that I showed. Intellectually, we have really thought through and these things and can solve them, but the acting part is also a difficult part. So we also have to somehow investigate and foster system acting. So if we see what disciplines do we integrate, we have as human systems integration. We have already integrated human factors. We have already, here now it's working, integrated system engineering. We have integrated our organizational scientists. One forefront, which we are now doing, trying to integrate, is the designers, the design thinking. There's a lot of energy in this relatively new domain. And I'm personally convinced by integrating designers, and we are doing this systematically in our teams, we can also win as a human systems integration society. And of course, all these different perspectives work together, and we are probably the ones who can integrate those perspectives. So looking at the future of this human, we have already addressed its cognition. That's rather good. So we are talking about intelligent system, but what is intelligence? We see, okay, it's a left side of the brain, the right side of the brain, but we also have a limbic system. We have feelings, we have an embodied cognition, and now gradually also science realizes that we also need to address this. And Don Norman has sparked an emotional human systems integration, emotional interfacing, he's calling that. Organizational science has sparked a discussion on ambidextrous organizations, and I would also love to discuss an ambidextrous human systems integration and how do we combine all this in a way that it's holistic. So more problems, more questions than answers. And one of I think the last tension field that I'm addressing is between the subjective and the objective, where we as scientists, we talk mainly about objective data is accurate, but we also know that only subjective insight brings action. And this is also something where we have to do something about it and to combine this in a way, in a synthesis where we bring objective and subjective perspective into resonance that brings intelligent action, where we make subjective impressions objective and objective knowledge subjective. And once again, the arts has done the extra scouting and the exploration. They have taken our telepresence technology and have found a setup, if you Google the machine to be another, where somebody can really mentally be another person in a way that it's really feels embedded. It's a striking example. Just look at it. It's really good. So balancing subjective and objective, we are doing this by doing citizen science. So we are inviting normal citizens in our laboratories and discussing with them issues of automation, for example, how we can help handicapped people. We learned a lot from that discussion. And it's what Hartmut Rosa also describes as resonance, that we should go as a scientific and technical community into resonance with our stakeholders. And these laboratories that I also showed you are a good place to go into more resonance. And also, if we think about the populists, some presidents that try to ridicule science, that's really dangerous, right? And the only way to protect ourselves and protect this revolution that started with the Renaissance and also with the Enlightenment is to find allies. And I think the public society are allies. We can, all the experience we have so far is that this discussion is really fruitful. So we have to do this. The last tension field, really, I promise. Science and spiritual, I will leave it alone because of time reasons and also because we are in a scientific domain here, but we should solve it. So to bring it together, if we look at this challenge that Don Norman put us up in the 80s, it becomes clear that we need bridging methods that bridge those tension fields, that we need a dynamic balance, that we need to bridge those tension fields, and balance and synthesis in human systems integration for us are guiding themes and a set of methods, techniques, and procedures that systematically combine and bridge the areas of tension in human machine systems and its supporting processes. And the goal should be well-balanced systems. And if we take the old definition of NASA, we can make it much simpler, that we are an interdisciplinary science, craft, and art to integrate humans, technology, organizations, and environment into efficient, safe, user, and eco-friendly systems. Simple definition, the task behind is much more difficult, but the story we can also tell, hopefully, is really worth to pursue this. The story is that, yes, we conquered the planet. Maybe we almost lost the planet with all the problems we have, but we also innovated our way out of those problems, and we saved the planet, right? With intelligent human systems integration. So please help us to improve human systems integration. Help us to balance technology, humans, and Earth. Our proposals are balance yourself, synthesize, discuss with others to find new, better solutions, pick up somebody you love with a life expectancy maybe greater than 50 years, like my little niece, and then do human systems integration for these persons and with these persons in mind and heart. Choose projects with impact, develop and apply the best HSI methods. If you have questions, if you found mistakes, certainly send us your questions or answers. We will be happy to integrate this. This is not a one-way street. We want to go into resonance, into a fruitful discussion. I hope if we solve all these challenges that the future of mankind will be more like this, that we can also enjoy our leisure time. And if we look beyond this, we also see, if you have looked a little bit closer to our background, that there is a whole world out waiting. And these are real photos. This is not virtual reality. This is an imprint of reality. We have around 100 million stars in our galaxy. And the roughest estimate, the latest estimate of NASA, 1,000 billion galaxies. And this is a vast space of opportunities also. And of course, we have to first do our homework, our little spaceship here, to protect this and to foster this. But then also there's a big world out ready to be explored. And I'm very sure that human systems integration, hopefully intelligent human systems integration, is an integral part of this. So my presentation is over. Thank you very much for your attention, and thank you very much for the team you see here who helped me to prepare this presentation. My presentation is over, but not our task as a community to foster human systems integration, to develop this further. Also, the conference is not over. I'm really looking forward to your presentations and to a fruitful discussion. Over and out.